Okay, welcome back. I'm always saying at the beginning of every video. The derivative of a power rule. New rule. If f of x equals a singular base to an exponent where the exponent is a real number, then the derivative will be n x to the n minus 1. Now, what we will say, grab another piece of paper, what we're going to say is that when you have something like f of x equals x to the n, we will say that you bring the n down and you take 1 away from the exponent. All right. Now, Liebig's notation says this says the exact same thing as this statement. F of x equals x to the n, find f prime of x. So it takes 2 steps to be able to say what can be said in 1 step in Liebig's. And what this says in words is take the function x to the n. Okay, so what's inside there? Take the function x to the n and find the derivative with respect to the variable x, which is long and cumbersome and horrible, which is exactly why we invented that symbol. That symbol means this. And that's the notation, and I can't tell you how important it is. So what this says over here, don't get so freaked out. This is saying, okay, what if I have a function and I want to call it y? This dy by dx actually could have brackets around it, which says, please, it's very formal, please find the derivative of the function y in terms, or with respects to, in terms of the variable x. Now I agree, that's a lot of words. That's why we write it like this. Now, I don't know what y is in terms of x here. I just have y. But somewhere they told me that y equals that. So it becomes the derivative of x to the n over dx. This says find the derivative of whatever's in here in terms of x. The answer is, if it's still bothering you, good. We'll come back to it. We're going to keep doing it. Okay, so examples. Find the derivative of each of the following. Notice I didn't prove this rule. This rule I didn't prove. I proved this one. I proved it 2 ways. I proved it algebraically, and I proved it geometrically. I'm not going to prove this one. It is proved in your book. You're not responsible for the proof. It's too tedious for the scope of this course, so I'm not worried about it. Read it lightly. Okay, so here we are. So I have f of x equals x to the 8. How exciting. So what we're going to do is I notice it's got a single base, and it's got an exponent 8. 8 is a real number. 8 is a real number. It's in this form. So what I'm going to do is I'm going to say the derivative is equal to, bring the 8 down, x to 8 minus 1 is going to be 8x to the 7. That's it, guys. That's as hard as it gets. Yeah, I know. Write down. That's it. Okay. But then we do stuff to you, and we expect you to know algebra. So this doesn't look like that. This doesn't look like that. So what we're going to do is we're going to change this to look like that. How did I do that so quickly? Well, because I know that the square root has an exponent of 1/2. So 5 times 1/2 is 5 over 2. You got to be able to do that. So now the derivative will equal, bring that down, 5 over 2 subtract 1. Now, I expect you to know how to handle fractions. that'll be 2 over 2. So it's actually going to be 5 over 2x to the 3 over 2. Now that's my final answer. Okay? We could also write it like this. Okay? Get used to that. We could do either one. Over here. Uh-oh. That doesn't look like x to the n. I don't know how to do that. The only thing I know is if y equals x to the n, then y prime equals nx to the n minus 1. Now, I got to go back and talk a little bit because I just threw in some more notation at you. But if I'm going to say f of x equals x to the n, f prime of x equals nx to the n minus 1, can you see how it's very similar to just call that y? And so that would just be y prime. I hope you do. It's very similar to when we had x here, we had y here, and then we just talked about it as f of x. Oh, can't see that. Where we had x here, we had y here, and then we made it f of x. Okay. So, again, this does not look like that. Doesn't. Nope. But we can make it look like that. So we're going to change how it looks. Notice I don't put the little prime sign here yet. I have not taken a derivative. No, 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 no. All I've done is rewrite this. So the prime will be, bring the negative 4 down, x to the negative 5. Why negative 5? Because negative 4 take away 1 is negative 5. So it's negative 4 over x to the 5. Get used to writing it like that. Okie dokie. What is the derivative of the function x in terms of the variable x? Well, you do understand that this is x to the 1. So the answer would be bring the 1 down, bring the 1 down, and 1 minus 1, which is going to give us x to the 0, which is going to be, and from now on, I will never write all those steps. I'm just going to say equals 1. Okay? Now, if you want to know what's going on here, just to remind yourself, y equals x is that puppy. Over 1, up 1. It has a slope of 1. So it all kind of makes sense. It's all kind of fitting in for us. Okay. That's it. I'm going to stop you here, and I'll come back and finish off.